So in this next lesson, 1.14, yes, we are definitely out of order, but we are really honing in our inner freshman selves because we are going back to arithmetic and geometric sequences. Not my favorite thing in the entire world, but the book deemed it important and the higher ups told me I have to teach from the book. So we're going to do it anyway. So for this first one, very easy. Consider this sequence of numbers, 2, -4. And if you really played close attention in Math 1 when you were a freshman, maybe this has already sparked okay, I already know what the next number is. So fill in the next 3 numbers on the sequence or in the sequence based on a pattern that you observe. Write the rule you use to generalize the numbers. Repeat this at least 2 more times by considering a different pattern in the numbers. Okay, so from 2 to -4, I'm going to say we just subtracted because addition and subtraction are always the easiest. So I subtract, how did I get from 2 to -4? I subtracted 6. So subtract 6 again, -10. Subtract 6 again, -16. Subtract 6 again, -22. Isn't this so fun? Yes. Rule used, subtract 6. Okay, now let's do multiplication. What would I have to multiply 2 by to get to -4? So we went from a positive to a negative. So I know I have to multiply by a negative number. And then from 2 to 4 multiplied by 2. So I'm multiplying by -2, 8, multiplied by -2, -16, multiplied by -2, 36. So the rule that we used, multiply by -2. And then you're like, okay, Miss Sanchez, well, we covered addition, we covered subtraction, we covered multiplication / division. What else is there? Okay, now channel your inner kindergartner, okay? And think back to the most basic pattern you can think of. The pattern of just repeating. So 2, -4, and then repeat. 2, -4, 2. So what are we doing? We're just repeating the pattern. 2, -4. Kind of like if I gave you an apple, an orange. Apple, apple, orange. Apple, apple, orange. You're just going to repeat the pattern forever and ever. Okay, wasn't that so fun? Channeling our younger selves. Yes, it was. Okay. Next, we will often need to look at a list of numbers and make a guess about the pattern that exists. This skill can help us create models, graphs, and projections for the future. The process of making an educated guess or conclusion based on the evidence provided is known as forming a conjecture. So channel your inner sophomore Math 2 self. Conjecture is just an educated guess. The 1 year that I taught Math 2, this was one of the hardest vocab words for students to wrap their minds around. Why? I don't know. Go ask a sophomore or someone in Math 2. Conjecture is just an educated guess. No, you don't need to know that vocab word for my class, I don't think, but it's good to know it. You will need to make a conjecture in the next problem in order to write more terms of a sequence. So we are branching out further than just arithmetic and geometric, where we're always adding the same number or we're always multiplying the same number. We're taking it just one step further and we're trying to come up with different types of patterns. It's not always linear or exponential like this. So one of the most famous sequences is the Fibonacci sequence. And it follows an interesting pattern. Write the next 6 numbers in the sequence and describe the rule you are using to generate those values. Okay, since it's just me talking to myself, recording my voice, I have absolutely no idea how to make you discover this on your own, so I'm just going to give you the answer. Okay, so we have 1, 1, 2, 3, 5. And if you are super into patterns, definitely pause my video, take a second, and just try to figure it out for yourself. What's going on. Okay, and welcome back. Good job. All right. Did you get it? Yes or no? So we want to know, how did we get to the next number? All right. And a hint here in the Fibonacci sequence is that I feel like there should maybe be like a 0 here, or just exclude these two numbers out from your pattern. Okay. So it's actually a 1 plus a 1 gives you a 2. A 1 plus a 2 gives you a 3. A 2 plus a 3 gives you a 5. And then the next number is 8. A 3 plus a 5 gives you an 8. Okay, are you following along? Try to do the rest of them if you can. If you're like, I don't get it, just keep watching. Okay, so then it is the previous two numbers added together will give you the next one. So to find this number, we're going to add this plus this plus this. 5 plus 8, and that gives us 13. And then 8 plus 13 gives us 21. 13 plus 21 gives us 34. 21 plus 34 gives us 55. And 34 plus 55 gives us 89. So we also need to write or describe the rule you're using to generalize these values. It is that each number is the sum of the preceding two numbers. Apparently the Fibonacci sequence is like all over the place, like naturally occurring in nature. I have yet to discover where the Fibonacci sequence is, but it does appear. So if you're very into math, go ahead and do a little bit of research on that. A sequence begins with the first term, followed by the second term, and then the third term, and the fourth term, and so on. The nth term refers to the term in the nth position. So we don't know where it is in the sequence, but it's some future value. And we're just using n to represent that value. Kind of like x is an unknown. Now we're just using n. Why? I don't know. And is a generic expression that shows the general form for each term. Okay, so determine the pattern in the following sequence and write an expression for the nth term. It may help to label the term numbers label the term number for each term to see the relationship between the term number and the term and the values in the term. Okay, so let's just follow their advice and label each term number. So term 1, term 2, term 3, term 4, and term 5. Now remember, we're not always adding the same number or multiplying the same number each and every time. Sometimes it's just a little more vague than that. So if you want to go ahead, you pause my video and figure this out for yourselves. Otherwise, keep watching. So for this one, notice that we have, I don't know if you can see it, but we have a 2, and then we have a 3, and then we have a 3, and a 4, and a 4, and a 5, and a 5, and a 6, and a 6, and a 7, okay? And when we did that, it kind of matched like 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7. Okay, so there's definitely like a play on numbers here. So for the first term, this is n equals 1. Okay, so n plus 1 gives us 2. And n plus 2 gives us 3. 1 plus 1 equals 2. 1 plus 2 gives us 3. So n plus 2 over n plus 1, and n is 1. So 1 plus 3 over 1, no, 1 plus 2 over 1 plus 1 gives us 3 over 2. Okay, did we follow that? I'll do the next one for you. Okay, plus 1. And then we have, so for n equals 2, we'll plug in n. We'll go 2 plus 2 over 2 plus 1, and we get 4 over 3. Okay, hopefully you've caught on by now, because I don't want to rewrite that. Okay, so n is the term number. Our rule was n plus 2 over n plus 1. So if we wanted to find, let's just find the next term. Did it ask us to do that? Probably not, but let's just do it. Let's find the 6th term. So 6th term, we're going to plug in 6 for n. So 6 plus 2 over 6 plus 1 gives us 8 over 7. Isn't that so much fun? Oh, what a thrilling day we're having. Okay. I kind of already gave away the suspense. Sequences. We have arithmetic, which is always adding the same number to the previous term to get the next number. Geometric is always multiplying the previous term by the same number to get the next number. Hopefully that's just a little bit of a review. If not, please read through the examples here. We are going to skip number 4 and go straight to number 5. And do they give us the equation anywhere? Did I just totally skip over that? No, they didn't give us the equation. What? Okay, I'll give you the equation. I'll be nice. Okay, so we have geometric is g sub 1 times r to the n minus 1 power, and arithmetic is a sub 1 plus d times n minus 1. Okay, so g sub 1, first term, r, common ratio. It is the number that you multiply by to get to the next term. And down here, a sub 1 is our first term that's in the sequence, and d for common difference. It is the number that you add each time to get to the next term. Okay, so using those two rules that I so kindly gave you, identify each of the following sequences as arithmetic, geometric, or neither. If the sequence is arithmetic or geometric, write an expression for the nth term. So 6, 18, 54, 162. Hopefully you catch on to this a little bit faster now that you're older. You've already seen it before than my freshmen do, because this always takes them a long time. So when we are adding, we are going up or increasing or decreasing values at a very consistent rate or a very slow rate. When we multiply by a whole number, we are increasing our values very quickly. We start small and we get big. If we're multiplying by a fraction, that means that we're cutting the piece into more pieces, or dividing. A fraction is the same thing as dividing. I hope you know that. So we are taking a large number, and if we're multiplying by 1/2, we're cutting that large number in half. So let's pick a number. Hopefully this works out. 180. We cut it in half. No, let me use 160. 160. We cut it in half. We get 80. We cut it in half again. We get 40. We cut it in half again. We get, what am I at, 20? Yeah. 20. Cut it in half, 10, 5, 2.5. Okay, we're going from big to really small. So, long tangent, first problem, 6, 18, 54, 162. Are we increasing at a slow, consistent rate, or are we increasing, hopefully you were able to tell that this was increasing. Are we increasing at a really quick rate? You're correct, we're increasing at a really quick rate. How are we increasing? Well, we're probably multiplying. So 6 to 18, what did we multiply? 3. 18 times 3 is 54. 54 times 3 is 164. So this is geometric. And we have 6 as our first term times our common ratio, which is 3, to the n minus 1 power. We don't do anything with n. N is the nth term. So if we wanted to find the 50th term, we'd plug it in for n. This next one, 1, 2, 4, 7, 11. Okay, so we're kind of going up at a we're staying with small numbers, but, so let's see, we're adding 1 to 2 is 1, 2 to 4 is 2, 4 to 7 is 3, 4. So we're not adding the same thing each and every time. For the laugh of it, let's see what we're multiplying by. 2 divided by 1 is 2, so we multiplied by 2. 2 times 2 is 4. Okay, so we multiply by 2. But 4 times 2 would be 8, not 7. So this one is neither. We can't multiply by the same number. We can't add by the same number. So neither. Next one, 16, 20, negative 16, negative 20, negative 24, negative 28. We are decreasing. Our negative numbers are getting bigger. So decreasing, staying kind of with small numbers, no big increases. So let's see, how did I get from negative 16 to negative 20? I subtracted 4. Subtracted 4. So this one is arithmetic. First term is negative 16. Oops. Yikes. 16 plus our common difference, which is negative 4. Oops. Negative 4 times n minus 1. You can also write this as negative 16 minus 4 times n minus 1. Either or. Totally fine. And then, hold on, let me see. Did I have you do this next one? I don't think so. Oh, I do. Okay. Number 6. Last one. You can't always identify a sequence from the first couple of terms. It might be possible to generate more than one sequence from the first 2 terms, just like the first example we did. So consider the following start of a sequence. 2, 10. Write the first 5 terms of the sequence if it's arithmetic. Write an expression for the nth term using the first term of the sequence and another expression using the 0th term. Okay, that was a lot. Let's break this down. Write the first 5 terms of the sequence if it's arithmetic. So easy. Okay, 2, 10. How did I get from 2 to 10? I added 8. So plus 8, 18, 26, 34, 42, 50. Just added 8 each time. Okay, then the nth term, so we want to generate that equation. We have our first term plus our common difference, which was 8 times n minus 1. And another expression using the 0th term. I have no idea. Write another expression. I have no idea what they're asking us to do. Okay, let's skip it. Okay. Part B, write the first 5 terms of the sequence if it's geometric. Geometric is multiplying. Okay, so 2, 10. How did I get from 2 to 10? By multiplying. I times by 5. So times 5 is 50 times 5 is 250 times 5 is 1,250 times 5 is 6,250 times 5. Yes, I needed my calculator. 31,250. And the nth term using the first term of the sequence. Oh, and another expression using the 0th term. That was this guy right here. Okay. I just skipped a step. Okay. Nth term will be the first term, so 2. Then how did we get to the next number? We multiplied by 5 to the n minus 1 power. And now we're done. Go ahead and do the homework problem.